Everyone, nice to see you. So I'm Mateusz. I will be talking to you about about augmenting your Ibexa DXP project with a private AI. But before we jump to that, let's look at this handsome guy. This is me. I would like to give you some words about me. I work at Ibexa for about 7 years. Almost 7 years right now. And I'm leading support team. I also live in Krakow, and I come from Poland. And in the spare time, in the free time, I like video games. I like playing board games. And also my hobby is that at my house I have home server, like Home Lab. Any of you have your home servers, like running Home Assistant, Plex, Image, NAS, Minecraft servers? What I have, this is really fun. And basically also what is fun, I try to find some substitutes for some commercial applications so I can host them locally and use them more privately. And I stumbled upon that you can do the very same thing with AI. So basically you can get AI, install it on your machine that you own, and run it locally. You might ask, why would I do that even? Answer is pretty simple. First of all, for fun. I'm a funny guy. Second of all, this is great for developers. You can use private AI, and private AI is great, you will see in a moment. And you don't have to pay for it. It's yours, at least to some extent. And the third of all, there are situations when some company policies or even law is forbidding you to send some sensitive information, sensitive data to like third-party services. So this is out of the picture. But you may ask, okay, easy to say than do, where I can get those AIs? There is like a page called Hugging Face. You can think about this like the AI geek community. They host a lot of models that you can use. At the moment when this presentation was made, so like 2 weeks ago or so, you can see the number of available, or maybe not if you are like on the last rows, the available number of models that you can use privately is over 1 million. So you can use 1 million different models, yes, but and I will be in this presentation for those examples. I will be using something called Llama. Interesting thing is, if that presentation would happen like maybe next week, I would be using different large language model. You probably know what I am thinking about. DeepSeek, yeah? What a time to be alive. But I will be using Llama, very nice name. This is the very popular large language model that's come from Meta. This Meta from Facebook. And what's interesting, you can get that, install on your machine, run, and it's free for commercial use. There are like 3 situations when you cannot use it. 1, to train other AI. 2, to use it for like military purposes. And the third one, if I'm not mistaken, if you have like more than 700 million users per month, you have to get special license from Meta. I will be using this model in the 3B size. What does it mean? This means that the model that I'm using was trained on 3 billion of parameters. The larger the number of parameters, the larger and more intelligent the model is, but also you need more resources to run it. Also, Llama is like simply text generation model. So you provide text, you will get text. And the last but not least, please keep in mind that models are static, at least this one is. And it was trained around September 2024. So if you are expecting it to give answer about something that happened after that time, it will have no knowledge about it. But we know where to get an LLM, where to get our model, but how to talk with this model. And here is another great piece of software. It's called OLlama. It's open source and MIT license, and you can basically use it as a platform, as a framework, to talk with your AI. What is great about it? It's very easy to install, and it runs on everything. When by everything, Microsoft Windows, Linux, macOS, and it supports a lot of hardware. Like, for example, it runs very well on M-series CPUs from Apple, so MacBooks. And it shows great results with NVIDIA GPUs. I will be running this on this laptop. It's a great laptop, but unfortunately, it does not have any AI-supported hardware, so I'm using only the power of the CPU that I have here. I will hope it won't explode, but we will see. If it explodes, yeah. And it's very easy to install. Those are the examples, how to install it on the Linux machine. So one command to install it, one command to pull the model. You can pull as much models as you like, but keep in mind they will take up some space on your hard drive. I think this Llama 3.2 model with 3 billion parameters is like 4 gigabytes or something like that. And you can run it with one single command, but you don't have to take my word for it. Let's see it in example. At least I hope you will be able to see in a moment. Oh, yeah. So this is, I pressed some buttons, and I broke it. The demo effect. Give me a second. Where is the mouse cursor? Yeah, it's here. And yep. So this is running on my computer. I have Wi-Fi disconnected, please believe me. And this is already when we can talk with AI. Let's ask it to write me. Write me an article about Barcelona. Use 200 words. Let's go. Yeah, it's thinking. It's thinking. It's doing something. Yeah, we have the output. So this is something that is generated out of this small box. And it's still going. And one great thing is that you can see it's quite fast, even on this hardware. But keep in mind, when I will showing you some demos later in the future, about a couple of minutes, it can look a little bit slower because we will be doing much more complicated stuff with it. That's the first thing. And also, it responds with tokens, so it gives you like this streamed response word by word. When we are dealing with that with Ibexa DXP, we will be waiting for the whole text to be generated before we will get the response. So yeah, it's working. Let's get back to the presentation. Yay. Let's take a look at another slide, which probably you are waiting for. So we're finally to the main topic of the presentation, which is to use private AI and Ibexa DXP. You can see a little asterisk next to the private word. That's because all the examples and the code snippets and everything around it that I will be showing you here today can be also used with OpenAI or any other solution that you want to use. But yeah, let's have fun with private AI, don't we? Another disclaimer is that to make AI work with Ibexa DXP, we need something called AI actions. So this is the framework that was multiple times already mentioned during our Ibexa Summit already. Long story short, it's an opt-in feature. We can install it very easily. If you can see it down here, it's only like running one single command, composer require Ibexa connector AI. But I also include the second one. Composer require Ibexa connector OpenAI. This will install your example files for OpenAI, which won't be using today, but they are great just to like take a look some things are done. They are good examples, you know. About these AI actions, another great thing is that it introduces also like the nice backend in our admin UI. And you will see this in a moment in action. What I will be showing you today is 4 things. First, we will create a Llama connector, because out of the box, AI actions don't know how to speak to a Llama. Then I will show you how AI can execute some functions on your code. Then we will deep dive into semantic search, which is a great thing. We will see in a moment. I cannot wait to show you. And another thing is context-aware answers. Yeah, let's jump in. The first thing is custom connector. I will be showing some code snippets here, and they can be quite big also. Don't worry if I will be going a little bit fast, because all code will be available in the GitHub repository. The link will be, and QR code will be available at the end of the presentation. So yeah, what do we need for AI connector? At least for the simple custom AI connector for AI actions, we need three things: action, action type, and a handler. If we take a look at the action, this is an extremely simple class. Basically, Llama is, what I said, text generator language, large language model. So we'll be providing text and expecting text as the output. We already have a lot of classes, a lot of blueprints ready with the framework to handle this situation. So only thing that I have to do, I'm defining an action. Action represents like intention that we will speak with AI and what we will provide it to it. And we are defining the get action type identifier. This is basically the identifier that we will specify for action type. And the action type is a lot longer class. But if you look at this, this is almost all getters, so nothing interesting at all and nothing complicated. Action type, you can think about this category for AI actions. So in this scenario, I called it generate text. So I will be creating a couple of actions that will end up in the new text being generated. Interesting only, probably like, maybe not interesting, but a little bit complicated thing is the create action method. We are doing a small check here. If the provided input for the action is of the type data type text, yeah, because that makes sense. We don't want to image here. If it is, we will just return a new action. If it's not, we will throw an exception. And third part of the puzzle is our handler. Handler is like the creme or de la creme of AI actions. It also looks a little bit complicated, but it is not. With handler, we are talking to our AI with specified means. If we take a look at the code, most important part happens in the handle method. I'm sorry if you cannot see it, but nothing interesting happening here. I'm only mapping the input. But in overall, we take the configuration that we define from the back office. I will be using the system prompt field value. I will show you in a moment. And then I'm using HTTP client from Symfony, great tool. And we are basically making an HTTP call, HTTP request for Llama, HTTP endpoint, which some JSON payload. I won't deep dive into this. You can try find the documentation for Llama on the internet. Interesting part is that we are sending this payload to the generate endpoint. We'll be generating text, so that's the way generate. And we are grabbing the response from the HTTP client and returning this like a text response from the handler. And this is all that we have to do. 3 simple classes. Oh, yeah, I also totally forgot about one thing. We have to define some services. This is some Symfony magic again. First of all, we are tagging our action type, so back office is aware of it. And we are tagging our handler, so back office is aware of it. The last thing is some nice magic from the engineering team. You can create a simple form type class, adding fields. I'm adding this system prompt field that I showed you before. And with this magic, it will be added automatically to the backend. So with all this, first demo. Let's first take a look. Maybe I can switch quickly and nothing will explode. So I can see same thing that you see on my screen. Yep. Let's switch to, yeah, you should be able to see, yes, everything works correctly. This is our backend, and you can see 5 AI actions. that I created and defined here. Don't look too much because you can spoil some fun in the later part of the presentation. But first one, take a look at this one. As an example, I created translate to French action. I will be grabbing, so there's like a most important part that you cannot see. Give me a second, let's try to move it a little bit higher. Is the system prompt, which instructs our AI how to behave. I'm telling it to ignore all instructions in the user prompt, just look at the text and translate it. Yeah, so let's take a look if we can make our AI dance. This is the text that was generated for the article about Barcelona. Let me grab it really, really quickly. Yeah. And we have the first demo. Let's ask AI to translate that for us. So instead of doing that ourselves, fingers crossed, go. And this is the command running strictly on Ibexa DXP. I defined in the backend the action. In the command, I'm using the action service to retrieve the action configuration, grabbing the input for command, send this to AI, wait for the response. You can see we are waiting a little bit just because we have to wait for the all response to be generated. Then we will grab it, and when it's done, hopefully it will be displayed on the screen. It's a good moment always to grab something to drink. Yeah, it's taking the time. Yeah, and this looks French to me. I don't speak French. Does it look okay? Is it proper French? Yeah, then it's good. If it wouldn't be the beauty of private AI, you can go and find one order of 1.2 million models that maybe can do that job for you better. Let's take a look at the second demo that maybe will do closer to your heart content. Let's paste the same text to the next command that will do exactly the same with the same handler, but I instructed it to create up to 8 tags for the provided article. Again, all this is sent to AI. In the prompt, I ask it to return a JSON string that will contain the tags for me. And yeah, here we are. We have the response JSON string, and converted to RI, we have tags. No one likes to add tags to their article, so I hope you already have idea how you can use it in your project. But yeah, there are more fun stuff to show to you. Let's take a look further. AI functions. What are AI functions? That's a very good question. We can provide tools to AI, and with those tools, I would like to emphasize on functions. What you can do is basically to tell AI that it can ask you to execute some code for it, provide it with response value, return value of that function, so you can make AI be aware and be available to access dynamic information. So as I said, AI was trained on a specific set of time, and it does not know anything that is happening now. But with function, you can describe a function to the AI, just like I would like to describe to my friends from Ibexa from the engineering team. I'm using taking a current weather as example. You said, hey, if someone asks for what is the current weather in a specific city, execute getWeather command, getWeather function, and this function will retrieve the current weather for the city for you, and is expecting one single parameter that is the city name. So when AI see a text prompt asking, hey, what is the weather in Barcelona? Normally it will say, I don't know. But here it will ask us, give me this value. I need this information to answer. You will give it back to you with because with something that is called tool calls response, you will receive this request from AI, and you can send it back to it, so it's now aware of dynamic context. Yeah, what to do with this? We need a new tool handler. It's almost identical what we already have. The only difference is we are passing another payload in our JSON called tool. You can see I have options, name of the function, description of the function, parameter name, and parameter description. This will come from the AI actions from the back office. Next, I'm sending this to the chat endpoint, not generate endpoint, because we will chat with our AI. And the last thing is that we will have to provide the value of function to AI. So we will only add to the second request that we'll be making the role tool and content and value of the message to something called messages. You can find in the documentation. I will don't go deep into the detail. Demo 2, Terry Crews is keeping his fingers crossed, so it must go well. Yeah, I have it here. What weather we should check? To what city? Do you have any suggestions? Again? Hamburg? Yeah, let's go with Hamburg. What is the current weather in Hamburg? One small disclaimer here, I have my Wi-Fi disconnected, so it's all private. So you will see in the moment, yes, AI is asking for the get weather result for Hamburg. I made that up. So this is like the random from 10 to 30 degrees Celsius. But AI asked us, hey, execute get weather function in your code and give me the result for Hamburg. And I said, yeah, get weather result is storm, 12 degrees Celsius. And we can see response here. Current weather in Hamburg is stormy with temperature at blah, 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 blah. You can see it responds dynamically. You may think, oh, what's the big fuss? Now we know the weather in Hamburg. But imagine, for example, sending like order number here and do something with that. Or maybe to generate article about Barcelona that last match ended with, yesterday match ended with the draw. So maybe you can give a discount for Barcelona fan or something like that because the football team didn't do that good yesterday. Yeah, do it whatever we would like with it to do. Dynamic content and automations are great examples. But this is not the end. I still have some fun things to show you. So semantic search. I'm so happy to show this to you. What is semantic search? It's a great tool. You have definition from Elastic Code on the top of the page. Semantic search is a search engine technology that interprets the meaning of words and phrases. I would boil by example when I'm comparing something, the practical approach. So I would like to tell you the difference between semantic search and the keyword search. Keyword search is a standard search. We are giving it a keyword, and it's searching to the articles, text, whatever. And then when it finds the keyword, yeah, those are your search hits, those are your search results. Semantic search is not only searching for like the word, but also checks the word meaning or the phrase meaning, and it searches for the text that is similar, also similar to what you want to find. For that, we need some magic from AI again. We need some vectors, embeddings, and vector store. Sounds complicated? It is a little bit, but we have tools that we don't have to think too much about it. We can just use them. But what I show you, the llama is text generating model. We need embedding model to do some magic with semantic search. And what we will do, those embeddings are the representation how AI interprets a specific string, specific text. And it interprets it as numbers, and that's our vectors. In PHP context, it will look like the array of floats. It can be positive and negative. Those embeddings tend to capture semantic of the text. And when we have some numbers, we can do some math on those numbers. And thanks to that, we can do some pretty interesting things. What is interesting that if you think about embeddings and those vectors, when you are thinking about the embedding of the question, the vector of this question will be very close to the vector of the answer. And to do something like that, we need embedding model. I'm using embedding model name that I cannot remember, but it's free, Apache 2.0, and it's very fast. We will take the query, convert it to embedding, And then we will search with this embedding for some similar results. But before we do that, we need some data to search for. So basically, we have to index our documents. In Ibexa DXP, those will be content, and store that in vector database, vector store, so we can do those vector math, vector magic on it. Sounds complicated, but when I show you an example, it won't be. So we need vector database. I'm showing you some of the big players. Interesting thing is, a lot of those are free or even open source. In examples, if you check my repository, that will be shown at the end of the presentation. I'm using Postgres. Let me take a sip. Who does not know SQL? So it's easy example, easy to check. And we need some further changes or additions to our connector, which we have to make it able to work with those embeddings. So we had text to text. Now we will have text to embedding. So I'm adding a new data type, which is embedding. It's very simple class. Just basically it stores the value of the embedding, which will be RI in PHP of floats. And the second thing is we need new action type because we also will be no longer generating text. We'll be converting text to those embeddings. And also we need a handler. Handler is exactly the same as like the first one. Only difference is at the bottom. Sorry, I didn't know that the screen will be so low. Basically, we are asking for where we'll be communicating not with Llama, but embedding model, and embedding model will return an embedding. So we are grabbing embedding from response, and we are turning in the handler this embedding. So that's why we need new handler, because previous one was returning text. So this is the part that I mentioned. We are grabbing JSON decoding the response, and then assigning it to some RI, and then returning as a new, with the data type that we just defined. I used one neat library. This is called PG Vector for Postgres Vector Store, and it's also free to use. You can find it on the GitHub here. And if you check out the example code, you can find it in the composer file. As you can see, this is purely running queries against the database. Very, very easy. But yeah, let's go with demo 3. But first, let me show you my beautiful project here and take a look at content structure. I have a couple of blog posts, some about footballers, some about Barcelona, some about Ibexa Summit. And I created an event listener that whenever a new blog post is published, I'm taking the body of the blog post, I'm split it in the smaller chunks, because if we were creating embedding, this is the best not to handle like the whole block of text at once. The good idea is to take like 100 characters. There are also nice libraries for doing those splits. And we go one by one for each text chunk. We create embedding for this, grabbing a vector, and we're storing that in database. So this is what I do on every time I publish the content, publish the new blog post. So if we are trying to think about it like in Ibexa terms, I'm indexing this for search. But let's take a look. I created a beautifully looking controller. Isn't it nice? I love it. It will compare keyword search, so basic search engine, with semantic search. Let's start with something simple. Hey, let's try. Barcelona. And you can see it's, by the way, you can see it's fast. I took the word Barcelona in the back, under the hood, converted it quickly to embeddings, and do a semantic search on the vector store. And let's look at what we have here. We have 3 blog posts returned for keyword search, and 3 for the semantic search. But you already can spot some differences. We have Ibexa Summit, Barcelona, and Lionel Messi here. But for the semantic search, Barcelona, Antoni Gaudi, and Ibexa Summit. So already, semantic search decided that for Barcelona, Gaudi was more important than Lionel Messi. Don't throw stones at me, those that are football fans. But let's take a deeper look. Let's now search for FC Barcelona. Oh, something is broken. Okay, let's try Lionel Messi then. Oh yeah, it works now. I think it has to refresh. It is a very simple controller. When we search for Lionel Messi, the keyword search returns only 2 articles. First one is Lionel Messi, the journal for the football legend. His article about Lionel Messi and Cristiano Ronaldo. So a word, Messi or Lionel, had to be also inside somewhere this Cristiano Ronaldo article. But we are expecting up to 3 articles, and semantic search also added Robert Lewandowski. There is no mention about Messi in Robert Lewandowski blog post, but AI was thinking like this: okay, Messi as a football player, so Robert Lewandowski is a football player. That's oversimplification, of course. So let's give another record about Robert Lewandowski. But to show you like really fun example, can I have some random football player name? Any? Someone said Maradona. This one I know how to spell. So yeah, let's go with Diego Maradona. I think this is how you spell it. And this is where semantic search shines. Keyword search, I have no article, any article about Diego Maradona. So if your user would search for Diego Maradona having this limited repository, let's say, it will just say, I have nothing to present to you. With semantic search, I was thinking Diego Maradona is a footballer, so we have 3 football players returned in the search results. I think this is a very powerful tool and a great one indeed. So yeah, that's all for this demo. Let's move forward because we are running out of time. And last thing that I want to show to you is contact our answers. What I meant by that, again, I mentioned you that AI was trained on the specific set of data. This AI is not that great set of data, to be also honest. But what would be great to make AI aware of our own data. So we can do some crazy stuff with AI, but working with own data. So, for example, I would like to make AI aware of Ibexa documentation. No one ever trains AI on Ibexa documentation. So if you just take any AI and ask something about AI documentation for Ibexa, there's very, very small chance that you'll get any answer. And if you would like to train your own AI, this can be very, very expensive. But to be honest, Chinese guys like 1 week ago showed it can be a lot cheaper than we thought. But the cool stuff is that you don't have to do that at all. And here comes the RAG for the rescue. And RAG is not a dirty carpet. In this, we are thinking about retrieval augmented generation. What does it stand for, that term? Exactly what it says. We are retrieving data, and we augmenting generation that is done by AI with this data. But this is not easy task to do. Those are the steps that we have to climb to follow with this RAG approach. So you might think, okay, we are sitting here for another 2 hours, but if you are paying close attention, we are already here. With semantic search, we can pass a question, and semantic search will find embeddings, vectors, that are similar to the answer of that question. Only thing that we have to do is retrieve those from our vector store, vector database, put all chunks, because we are searching for the chunks, not for the whole document, put the relevant chunks together to form a new document, and we pass that document to AI. Yeah? Sounds easy? Let's look at the code, if it's actually easy. This is exactly what I'm doing with this approach. First of all, I'm taking the AI action from Ibexa DXP, and I'm creating this embedding for the question that the user answered. Then, so this is where I'm creating this embedding. Next one is I'm asking the vector store to use a semantic search on the embedding for the question. And from the context retrieved, from the hits, I'm building like the wall of text. It can be long, it can be short. And the last thing is that I'm making another call with AI, but aside of just text, I'm also providing the context that we just retrieved. And Chuck Norris is wishing us good luck, so nothing can go wrong, so I'm pretty confident with this one. Let's take a look at the last example for today. Oh, maybe let's take a look first here. Oh, if I can aim. Let's get back to my beautiful project. Yep. Yeah. I have, with my blog post, I have Ibexa documentation, and I took article about image variation from our documentation, and I created this as a blog post, so it got indexed to our vector database. So now, if I ask question about image variation to AI, it should be able to answer. Let's see. What are image variations available out of the box in Ibexa DXP? This is the moment when the laptop can explode because it's doing some heavy lifting. So yeah. First, we are creating embedding of the question that I just asked. Again, we are making semantic search for that. We are retrieving relevant information, what semantic search thing is relevant. Then I'm putting together everything to create a document that consists semantically relevant, semantically similar information. And then I'm passing this as a context to AI. And it's already done thinking, and it says that image variations available are tiny, small, medium, and large. So as you can see, now it knows Ibexa DXP documentation and can help us with our problems. Yeah. Let's get back to the presentation. It's exciting, yes? It's quite nice. Thank you. It's very good to see like some heads nodding. Thank you also, Chuck. Let's move forward. And so I have some final words for you. Last year, you probably see this meme that was hovering around the internet when some lady said that she, when hoping for AI, she was hoping that AI will do her dishes and cleaning for her so she can focus on her art. But instead, AI is doing her art for her so she can focus on doing dishes and cleaning up the house. I think that with Ibexa DXP and our great AI framework, we can do exactly opposite. We can push AI to do chores so we can focus on important stuff. And that will be all from my end, so we can do, if we have still time.
Yes, we have time for like up to 2 questions, I guess.
Yeah, so if there are any questions, I would like to answer him, and yours. Yeah?
Yeah.
Let me take a quick sip.
Thank you. What kind of hardware do you have? Any graphic cards on your laptop?
No, just CPU. And this is probably worst case scenario for running LLMs. This is like Intel Core Ultra 7 and with Intel graphics. And this is not at all supported, I think. But if you have like NVIDIA GPU, especially like the RTX series, like with a lot of RAM for 12, 16 gigabytes, you can run those LLMs in the graphics card memory, and it's a lot faster, and it's very, very nice. Also, like the hardware from Apple, M-series processors, I think they have like AI cores, magic in the CPUs, and they are running a lot better than this laptop. And also, to be honest, some people are running those on Raspberry Pis, but it's not a great experience.
Thank you. It's impressive.
Thank you. Do you have any other questions? If we don't have any, you can always grab me somewhere around the corner. I'm not hiding, at least I try. and I don't bite. It's after lunch.
Okay, so thank you, Mateusz.
Thank you.
I personally feel
Oh! Can we put the slide back? I promise you some code. So here are some contact information for me. This is my email address. You can reach out to me on Slack as well, our community Slack. And this is the QR code that should point you to this address. One big disclaimer. The code in this repository is something that I called presentation grade code. So it's good for reading, good to get overall idea, but don't use it on production. Thank you very much, and have fun at the summit. We still have some more nice things to show to you.